Alright, so for the first one we're going to start off and we're going to do the off-bar diagram for thallium. Where's thallium at on the periodic table? Well, it's number 81. Right there. So, we have to start off, and this is the arrow diagram, so we're going to start off with 1s, and we have an arrow going up for helium, down, or arrow going up for hydrogen, down for helium. Then we're going to go to 2s, and we have lithium and beryllium, and then 2px, 2py, 2pz. And remember, each one has to get 1 before it gets its pair. We know that these are all going to be full because we're going all the way down the periodic table to 81. So eventually we should have 81 of these little arrows drawn out. Then we're going to go to 3s, and then 3p, x, 3py, 3pz. We have arrows for all those. And then 4s. Now this is when it gets crazy. We're right here. And now we're starting for the 3d. Remember, it goes down in energy level because there's so many electrons. And it should have 5 orbitals. Each one gets 1 before we get its pair. And that takes us to 4p. And those all get 1 before we get its second, which takes us to 5s. So now we are 1, 2, 3, 4, 5 at rubidium and strontium. We still have a ways to go. Then we are at 4d. And then we go to 5p. Almost there. Now we're on to 6s. Okay, and this is where it gets crazy again because we're right here and we have to go down to the F block and go through the F block. So remember, when we get to the F block, it's going to go down 2 energy levels. So 6 minus 2 would be 4. So we're in the 4F, and we have 7 of those.
Come in the morning. I'll tell him if you need to. I'll tell him you were here.
So 1, 2, 3, 4, 5, 6, 7. Each one gets 1 before it gets its second. The reason I'm going so fast is because I know this is totally full. So then that's going to kick us back up to the D block again. So now we are up to 5D. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. Next, we are here. We're finally to where we need to be, and that's going to be the 6px, 6py, 6pz. And we only have 1 there. That would be thallium. So, if we counted all of these up to double check our answers, we should have 81 arrows. So, just so you know. That's a lot. Do we have 81 arrows? You don't know? Did you get lost? Okay, where'd you get lost at?
I thought after this is 4s.
But you're at 3p or 3d, so 4, so that should be 5s. 5s. Because you're already at the 4th energy level. Okay.
Is that right?
No, this should be 4s, then 3d, then 4p, and then 5s too. Yep.
Are we gonna have like a really big problem like that in the quiz test tomorrow?
Maybe.
Can I see this?
Yeah, definitely. Okay, so let's move on to the next ones where we have the unabbreviated configurations below. So these ones aren't the alpha, these are just going to be the 1s2, 2s2, that one. So we have copper. Copper is going to be Cu, and Cu is where on the periodic table? Why can I not find it? Oh, right there, 29. Okay, so we're going to start off with 1s2. That's hydrogen and helium. Then we have 2s2. It's lithium and beryllium. 2p6. We're going to go 3s2. 3p6. 4s2. 3d9. Okay, the reason it's 3d9 is 1, 2, 3, 4, 5, 6, 7, 8, 9. It is in the third energy level because there's so many electrons that it falls down on an energy level, and it's 1, 2, 3, 4. So next one is neon. We have neon. Neon is right here, number 10. So actually too, if you add all of these exponents up, they should equal 29 too. So that's another way to check your answer too. So if we have 1s2, 2s2, 2p6. Okay, so if we had 6 plus 2 is 8 plus 2 more is 10. We should get the atomic number of neon. Now we have francium. Francium's all the way down here, so we have a lot to go through. So it should be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. And we're going to keep going. I actually might put an extra space here. Why won't it let me end it? Okay.
Good.
4p6, yep. So that's gonna go to
5s2.
yep, 5s2, 5s2, 4d10, 5p6, 6s2, which shifts us down to 4f14. Then it'll be 5d10, then 6p6, and then 7s1. How do you find density? Do you times these two? Oh, you divide them. Oh, no. No, you're not trying to find density. You're trying to find the mass. So you're going to times these two. Yep.
Oh, yeah.
Yep. You're fine. Okay, so that would be the correct one for francium. Next is going to be uranium. I'm going to see if I can get another space in here. Because uranium's way big too. Okay, uranium. We can actually continue on from that one too if we wanted to, but okay, so we're going to go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2. Then uranium is right here. So it's going to be actually 5f1, 2, 3. 3 would be correct. Okay, so remember when you go to the F block that it is down 2 energy levels. You go back up to the D block, then you're going to add an energy level, and that's how you get it. Cabby says okay.
Is this just 9?
Nope, because you do count that one. Next one, it says write the abbreviated for the electron configuration below for the elements. So we do have gold. Gold is AU, right? Yep, 79. So then we can look at our periodic table here. So we have gold right here. So what we do for the abbreviated is we go back to the noble gas that's before it. So that's going to be xenon. So we'll put that in, okay, we'll put that in brackets. And then it's going to take us to 6, so it's going to be 6s2. Then we're going to go down to energy levels because we've got to go down to the F block, so it's going to be 4f14. And then it's going to take us to 3d9. Oh, not 3d, 5d, sorry, 5d9.
I like these.
Next, we're going to do cobalt.
Oh, okay.
Cobalt is CO. So we have to go all the way back to the noble gas at the beginning, which is going to be argon. Put that in brackets. And then that's going to take us to 4s2. And it's going to be 3d1, 2, 3, 4, 5, 6, 7. 3d7. And then we have tellurium. Where is tellurium? Well, tellurium is number right there, 52? Or is that 52? 52? Yep. So we gotta go to the noble gas before it. So all the way back, jump up, so it's krypton. So it's gonna be KR.
I'm done with my test.
All done? Perfect. Thank you so much. I appreciate it. KR, and then that's going to take us to 5s2.
Ruben Velasquez, please come to the office. Ruben Velasquez.
And then it's going to take us to 4d10, and then 5p4. Then Einsteinium. Which is number 99 in the F block. Okay, so the noble gas that's going to be best to use for that one is going to be radon, Rn. And then so it's going to be 7s2. And then I'll go 5f, and then 1, 2, hold on a second, mine's better. My periodic table's on here is better. Well, maybe if it lets me use it. Go.
Just kidding.
Yeah, nope, not working. Okay, so we're gonna do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Next part, it says determine what elements are denoted by the following electron configurations. So, easiest thing to do is look at the last element. We know what's going to be in the third row in the P block, and we can count that. No, we know that has 4 electrons. So if you go to the third row, P block, 1, 2, 3, 4, it is sulfur. Next one, we can go 5s1. So we know it's in the 5th period. S block, and it only has 1 electron, so it's going to be rubidium. Next one is 5p3, so it's 5th period. 1, 2, 3, 4, 5. It has 3 electrons. 1, 2, 3. It is antimony. Sb. Then 5d6. So remember, it goes 3d, 4d, 5d. So 1, 2, 3, 4, 5, 6. Osmium. If you're not understanding this, you can count it out too and go through. Start off with xenon, then go to the S2, then go down through the 4F14 and the 5D6 as well.